Good afternoon. I'm Jay Reynolds with Angel Petroleum Technologies of Vivian, Louisiana. This afternoon we're going to service a well which uses our BlackStorm production tubing that we've developed in conjunction with Parker-Hannifin Corporation. This is the first well we equipped with downhole pump and motor on flexible tubing, and that motor ran for about 3.5 years. We're going to service it today and show you how easy the most complex operation you can do with this system is. If you know nothing about the oil business and I ask you, what should I use as plumbing if I need to move 500,000 barrels of water a month? Number one on your list of what I should not use would be mild steel tubing, and that's what we all use. Our production technology here is fundamentally unchanged since the 1930s. This unit previously had a pump jack. With that you had to have a slab, pump jack, gearbox, pitman arms, bearings, weights, 27 moving parts. We pump 12 strokes a minute, and that's 13.4 million rod wear strokes a year. We eliminate all of that with this system, which has nothing that can corrode and has only one moving part. As far as I know, this is the only production system available in the oil field which does not begin corroding the day it leaves the factory. And this is how our tubing is made. This is a short section. It's comprised of 3 parts in cross section. That's a 1-inch diameter core tube through which we produce about 540 barrels of fluid a day using our particular pump and motor combination. Your application may differ. We use a 7.5 horsepower Franklin motor driving a 5 horsepower Grundfos fluid end. We oversize the motor 50% with respect to the pump because we pump a fairly viscous oil. It's API 21 gravity. So we have the 1-inch diameter core tube. We've got integrated into this and sheathed in ballistic nylon a 3-conductor number 10 wire which powers our downhole motor. Next to it, inhibiting stretch in the system, is a 3/16 inch pre-stretched stainless steel aircraft cable. The electrical cable and the stainless retention cable are terminated at each end of the tubing into a billet cut stainless steel pressed on fitting. It's really the most rugged kind of a hydraulic fitting you could ever imagine, since I know you're familiar with those. The wire is terminated out here, and the terminal threads are 1-inch male pipe thread, NPT thread. We run on top of that an 1.5 inch bushing, which allows us to land the assembly. This well is the first one that we equipped with flexible tubing using the downhole pump and motor combo. This ran about 3.5 years, and today we're going to service it for the first time. We're going to do the most complex servicing operation you'll ever have to do with this. It's the equivalent of a barrel job using a workover unit. But instead of having a workover rig and 4 guys and workers' comp like you can't believe, we're going to do this with 1 man, nothing heavy over his head, and the entire operation from start to finish, from drive up to drive away, is less than 45 minutes. Oh, you'll need tools, a 1/2 inch wrench and a small pipe wrench. The lifting bail is screwed onto the bushing. It just gets a good snug hand tight. And that's it for manual labor. As the tubing's fed onto the spool, the T-bar, which is used to keep the fitting in alignment, is attached to the flange of the spool. From this point forward, it's a simple matter just to spool up the hose in its one continuous length. As you'll notice, Jason's tracking the spool from side to side, and that's how we handle having the hose lay flat as it's retracted. The spooling trailer is powered by a little 10 horsepower motor. It drives a hydraulic pump. The hydraulic pump drives the motor on the take-up spool and the hydraulic cylinder underneath the spool, which is tracking the spool back and forth. You can run this operation all day long on about a gallon of gas. One person, if they had that many wells to service, could easily service 4 wells a day by themselves. The more the tubing comes out of the hole and is wrapped on the spooler, the faster the rate of retraction is, which works out real well because the more you have out of the hole, the lesser the load on the spooler. As you can tell, Jason is really breaking a big sweat here. On our other unit, we have a remote control. We'll have some video up shortly of him doing a well servicing, sitting in a lawn chair under a golf umbrella, drinking an iced tea, doing this whole operation with a joystick. This is the terminal end of the BlackStorm production tubing, which terminates in this billet-cut stainless steel 1-inch fitting with NPT threads. This is the tie-off for the pre-stretched stainless steel aircraft cable that controls any stretch in the tubing. We'll go through a union, and this way if there's ever any service needed, all you have to do is take the union apart, stick on another pump and motor. Because the system is so easy to service, we can take a motor that we've pulled out of service that we had been run on steel tubing and run it on this system until it completely fails. And that way we're getting absolutely the very last bit of life out of every one of the components in the system we use for oil production. Like every other stripper well operator, I'm fighting a losing game. Unless we do something different, unless we change the rules, unless we creatively change the game, every year it's costing us more energy input, more kilowatts of electricity to make fewer and fewer barrels of oil. That's just the nature of geology and depletion. So we had to change the game. The fact that we were able to come up with this system is strictly due to the fact that I had the good fortune of running into Mike Swales, at the time chief engineer of the Parflex division of Parker-Hannifin. It was Mike and his engineering team that understood the opportunity and how many thousands of wells throughout the United States that could be economically re-equipped with this system. By the way, this system with all new componentry, one moving part and nothing can ever rust, is about $9,000 less than buying comparable new equipment with the traditional beam pump. Jason's working. I'm going to ask him a couple of questions for you. How many of these could you do in a day if you got a late start, had bad weather, and you took a long lunch?
Probably 4.
4? And what's your total time to service if you do the worst job you could possibly have to do from drive up to drive away with the well pumping?
Probably 45 minutes at night.
Okay, that'll work. So what we've saved by doing this is to call a workover rig out, which is, since I'm a small operator, we have to hire a contractor. Jason's being able to service a well like this saves us about $500. And here's something you don't get from Subway.